involved into building mobile robots. These are dual-use technologies, and what we are building, we are calling it robotic general intelligence. This typically deal with large infrastructure companies, typically oil and gas, steel and iron, and your defense sector. So, yeah, I'll just say next screen, you can just do that. Yeah. So we are solving one of the most pressing challenges of today autonomous unmanned solution. These are how these robots or unmanned system, may it be anything, ground you are seeing here, air, water, underwater, or a humanoid or a robotic arm, can operate in high heat environment, extreme dust, and unstructured ecosystem. So currently across the globe, people are trying to solve. We have taken a different approach where we believe that we have to iterate and reiterate onto the hardware ecosystem so that we could solve these challenges. And the first customer or the first area that we have selected was into the area of steel and iron industries, because of the obvious reason, all these three things are abundantly available. And if our robots can perform here, we could easily do vertical and horizontal deployment across other industries. Next slide, please. To solve this problem, we have ideated a three-part solution, what we call as Orion. So Orion stands for the first part, or what we call as software stack. It's an enterprise-grade software that is typically running on three systems. You can see an Android tablet coupled with a very user-intuitive gamepad, an industrial-grade robot controller, and a laptop. Similarly, this can be given to any other web OS and other things. So a cross-compatible enterprise-grade software. Then we are on the other part where we are developing what we call as intelligence. This is somewhere around TRL level 3, and we are focusing on all the 4 areas of robotics that we have differentiated in our journey, that starts from perception towards localization, articulation, and interaction. I'll deep dive into on later stage. And the last one is a physical hardware that you have seen, the first platform that we have developed, which is vertically integrated by our patented subsystems that we have found are loopholes into the industry that typically enables these robots to perform in the contested environment that we have, or I have talked in the previous slide. Next slide. So adding up to these, you could say, subsystems that we have developed, these are certain patents, certain critical subsystems that we have developed. You can see the first few of them, which are displayed on the that side of the table. These are subsystems currently deployed onto the robots, enable us to operate in high heat environment upwards of 120 degrees centigrade. The coming video, you'll see how the robot can operate on 60 degrees centigrade. Adding up to that, next slide, please. Next slide. Yeah. Then these are certain other subsystems that again we have developed. These enables us again to operate in high heat environment, typically protecting our robot with the AMI interference, with the EMC interference that happens in these kinds of contested environment. The second one is the belt that typically enable a very basic differential drive system to go in all-terrain kind of a facility and solve user problem, help them to scale their operation, help them to make their operations autonomous, increase the productivity, increase the overall safety and the quality of the product while reducing the manpower. So this typically enables them to also reduce their operational cost. We have seen further few deployments across industries, and slowly and steadily we are moving it. Next slide, please. Now these are certain subsystems which are coming, which will enable us to develop our autonomy stack, and we are building upon it. So the first one, if you could see the radar, we are deploying a radar, developing a radar that's you could say a low speed small area, high point cloud density radars that are typically enabling us to deploy autonomy in these kinds of constrained environment. This can penetrate thick sludge, heavy dust of 50 directly attached to the surface. So these are something that we are developing. The second one is when we talk about robots, robots cannot work individually. They need a fleet. They need to work in conjugation with each other to solve real-time operation challenges. So that's the another hardware that is under development. And the last one is a full end-to-end actuator that again we are developing. It's under TRL level 3. So these are the few subsystems that are coming us that enable us to build any kind of unmanned systems which are available so that we could solve the real challenges of the industry that are there, not only focus on logistics and the other areas which we see right now, which the robots are there available into the market. Next slide, please. This is a small video on how different payloads can be integrated on the top of this specific rover and solve very specific user-related challenges. What we are trying here is to build a small revolution that we have seen with robotics manipulator back around 2 decades, where basically these manipulators were built, deployed by the manufacturer itself. Slowly and steadily, the ecosystem came. Now, the robots are only being manufactured. They are working on the ecosystem, whereas the deployment is taken care by the vendor partner. Similar ecosystem we are building. This is a real-time video of how our robot is working in one of the plant. The temperature is around 60 degrees. We are doing a lot of trials. This is with railways. You can see the high inclination or the steep that is capable of maneuvering. Other than that, we are doing a lot of trials with Indian Army across different terrain. One of the mountainous terrain where you can see a robot attached with a shovel payload. This is swampy or a massy kind of a thing where basically sludge and other things are there. And here you can see the robot is running on a river bed. So this kind of all-terrain capabilities we have built in our system. And this is a 100 kg payload capable system that can be integrated with different subsystems. Next slide. Now moving from the hardware part towards the intelligence part, where what I have told that we are focusing on the 4 criticalities, what we have differentiated in our journey. Adding up to the first term is perception. What we are trying to do here is a build SLM, we are building a SLM-based model that would be integrating in all the 4 areas to deliver autonomy at scale at our user end. This is one of, you could say, one of the technology that are at TRL level 3 and 4. We are testing in lab. Already this specific system have level 2 autonomy, which has been deployed in client end. We are testing level 3 at our end, and slowly and steadily we would be moving towards. So we are building sovereign autonomy for unmanned systems, typically focused on unmanned ground vehicles. Next slide. Now the last one is an enterprise-grade software that enable any of the user to operate these kinds of robots, send basic commands so that your job can be done. So it can work in any of the cross platforms. You can see 3 systems already working onto a table. Anyone can connect, can control it, can send the data to it. One is working real time. You can see the video which is running onto it. Other 2 can again be connected. So anyone working on unmanned system can use this software and usually deploy a user terminal onto it. Next slide. Next slide. Yeah. So in the journey, what we are trying to build is low volume, high complexity manufacturing area where basically we could create all these kinds of technologies, all these kinds of product that could really go into the subsystem with a very different approach of vertically integrating the subsystems, where basically the performance would be unmatched, the technology would be unmatched, and we could easily compete with the global counterparts. We could easily compete with, you could say, the people who are working in it, starting from 44,000 square feet R&D area with a 20,000 super build-up space that we have kept up, and 20,000 we have left only for testing and manufacturing purposes. The second one is an electronics lab that we have set up, again a class 8 grade clean room that we have, adding up to the software and intelligence lab that is there. And we have a very keen focus on materials, because what we have seen, they are giving a lot of edge when we talk about deploying in contested environment. So you could see we have developed a whole belt manufacturing process That's first time developed in India, and that's what we are moving ahead with. Next slide. Adding up to these are the people who have supported us in our journey. From last 5 years, we have established this company back when I was in my undergrad. From that time, we are running it successfully and profitably as of now. So that's the way we are moving in. And these are the certain people, certain organization who has helped us in our journey, who has helped us to deploy the tech that you are seeing right now. Next slide. These are certain achievements that we have achieved in, you could say, our journey of 5 years. Starting from this year, we were one of the runner-up in Dell Entrepreneurs Challenge Season 2. Adding up to that, we were the winner last year for Indo-Japan Pitch Fest. And next slide. That's all. Now, anyone who want to operate this, it's here, it's working right now. We have a handheld controller, which is very much user intuitive. Anyone can have a live demo onto it and see how the ecosystem, how the things work. Typically, we could deploy this into the industries that we have talked about, that are steel and iron, oil and gas, energy sector, and we are moving in defense also. So we have seen certain deployments starting from big players such as Tata Steel to JSPL, JSW Group. So all the steel index major are working with us. And we are slowly and steadily moving into oil and gas also. HP is one of our partners who are helping us to develop level 0 robots, which are, you could say, one of the most complex technologies. Right now, not available across the world. People are developing it. And on a similar way, we are doing a lot of NCNC trials with Indian Army. I come from a place called Jharkhand, which is next to West Bengal. There are 2 IDEX that has been given to Jharkhand. One belongs to my co-founder and one belongs to me. So we are working with Army also, and that's how we are growing. I'll just have a small demo of the robot that could enable you how this thing works and how user intuitive it is, just like a gamepad. That's all. Thank you for patience hearing. Any questions? Would love to take.
So open house, any question? Okay, we have one. Can we have a mic for the gentleman, please? একটা mic, please pass করো.
Hi, my name is Shantanu. My question to you is whether this robot has got any kind of autonomous feature, whether it can take its own decision in certain situations.
So basically, I've already mentioned we are at level 2 autonomy. Level 3 is being actively tested. So decision making is a very basic capability that we have. So when we talk about autonomy, the main challenges lies is unstructured terrain and the daily changes that we have in day-to-day life. We are building autonomy that the robot could go in those kind of contested environment and take decisions autonomously. So yes, it has, but it's a technology that is under development currently.
Okay, thank you so much.
Any more question? We can take one more. Yes, at the back. Pichone.
I guess NVIDIA has Omniverse and Cosmos, right? So that physical learning transferred into a virtual reality, and so that it saves some of the iterations. Are you applying that?
So as of now, no. So we are using, yes, we are using an NVIDIA platform itself. But the Omniverse, what you have told, very specific is the ISEC, what NVIDIA is using. So I told you, we are developing our own autonomy. We want to develop the Indian sovereign autonomy for unmanned systems. So we are building that. That's why we are at level 2. These kinds of deployment with third-party stack, either with ROS or other things, can be done very easily. But we are trying to build our own autonomy stack from scratch. So right now, we are at level 2. But no, we are not using that.